Dear students, welcome to our science episodes. Today we are going to discuss electric current and cells. Electric current and cells. Sources of the electric current. Electrochemical cells could be the source of an electric current. They convert chemical energy into electric energy. The type of generated current is called direct current. For example, the dry cells and the batteries. Another source is the electric generators or dynamos. They convert the mechanical energy, the mechanical kinetic energy, into electric energy. And the type of the generated current is called alternating current. For example, dynamo. This is the dynamo. Types of the electric current. We have direct electric current, as we said before. It's unidirectional. It flows in one direction. If you can see here, this current is flowing in just one direction. Here also, the current is flowing in one direction. This is called direct electric current, and it has constant intensity. The source for the direct current comes from electrochemical cells, such as dry cells and batteries. And it can be transferred only for short distances. It cannot be converted into another type of current like the alternating current. And we use this direct current or the DC in electroplating processes and operating some electric appliances. The other type of the electric current is the alternating electric current, or what we call the AC. It's variable. It flows in opposite direction. It can go forth and back, forth and back. If you can see here, this is the electric circuit and this is the current. It can go in both directions. It has variable intensity, not fixed. And the dynamos or the electric generators are the source of alternating electric current. It can be transferred for short and long distances, from electric power stations to factories and houses. And it can be converted into direct current. We use the AC or the alternating electric current in lighting houses, streets, and operating electric appliances. Methods of connecting the cells in an electric circuit. Several electric cells can be connected together to form what is known as a battery. So we have multiple cells and we can connect them together to form a battery. We can connect them in a series connection, like here. These are cells. They are connected together to form what's called a battery. The opposite poles are connected together. So if you can see here, the negative pole is connected to the positive pole. Here we go again. The negative pole is connected to the positive pole. It's done by connecting the positive pole of the first cell to the negative pole of the second one, then connecting the positive pole of the second cell to the negative pole of the third one, and so on. Another type of connection is the parallel connection, where the similar poles are connected together. So we are connecting the positive all together, the negative all together, to form a common positive and negative poles. It is done by using a copper wire to connect the positive poles all together as one big positive pole, and the negative poles all together to work as one negative pole. How can we measure the electromotive force of cells connected in series? Series connection means that the cells are connected with opposite poles facing each other. So negative to the positive, negative to the positive. How can we measure the electromotive force of these cells? The electromotive force of a group of different dry cells connected in series equal the sum of the electromotive forces of these cells. So we are going to add them together. E1 plus E2 plus E3. The total will be the electromotive force of the whole battery. So if the electromotive force of E1, cell number 1 I mean, 1.5, E2, 2, E3 equal 3. So what is the electromotive force, the total electromotive force of the battery? It's E1 plus E2 plus E3. It's 1.5 plus 2 plus 3 equals 6.5 volt. What if the cells are connected in series? What if the dry cells are similar, are having similar volts and connected in series? So if we are going to measure the electromotive force, we are going to multiply the number of cells by any voltage. So the electromotive force of the whole battery equal N, which is the number of the cells, times the voltage of one of them. We will take E1. So if the electromotive force of E1 equal 1.5, E2 1.5, E3 1.5, so the total electromotive force of the battery equal 3 cells, this is the total number of the cells, times 1.5 equal 4.5 volt. Now the relation between the electromotive force and the number of similar electric cells connected in series is a direct relation and can be represented by this graph. The y-axis represents the electromotive force and the x-axis represents the number of cells. Can you see the relationship? It's a direct relationship. This means whenever the number of cells will increase, whenever you increase the number of cells in a battery, the electromotive force will increase too. How can we measure the electromotive force of cells connected in parallel? The electromotive force of a group, if they are similar dry cells connected in parallel, so the electromotive force is the force of only one of them. So the E battery, the electromotive force of the whole battery, equal E1. If the electromotive force of each battery equal 3.6, so this is 3.6, this is 3.6, this is 3.6, and this is 3.6. If I want to ask you about the electromotive force of the whole battery, you will tell me that it is the electromotive force of one of them only, which is equal to 3.6 volt. Here the relation between the electromotive force and the number of similar electric cells connected in parallel is represented by this graph. The y-axis represents the electromotive force and the x-axis represents the number of cells. Time for questions. If you have 3 dry cells, the electromotive force of each cell is 1.5 volt. Show by drawing how to connect them all to get a new battery of highest. One of them will be of highest electromotive force and the other will be of lowest electromotive force. So you have to form 2 different drawings of 3 dry cells. Each of them has electromotive force of 1.5 volt. And you have to show me how you will connect them to get a new battery. To obtain a battery of high electromotive force, the cells are connected in series. So, in this situation, the electromotive force will be 1.5 times 3 equal 4.5 volt. This is in case that I want to get the highest electromotive force. So I will connect these batteries in series. What if I want the lowest electromotive force? I will connect them in parallel. So the electromotive force will have the amount of only one of them, which is 1.5. Dear students, thank you for watching and waiting for you in other episodes.